Hello everyone, welcome to Disha program. We are powered by the Sarat Chandra IAS Academy. In Disha program, we educate and teach the young minds of our country about various different things. In today's video, we'll be talking about the earth slowing down. We'll see what is causing this phenomena and what is the future ahead. Alright, let's start with the basics. So what is in the news? So this is our earth. And we have divided the earth into some hypothetical lines or regions, let's say. Okay, so these regions are hypothetical and they do not exist in real. One of the reasons that divides the earth into two parts is known as the equator. So these lines are made with reference to the movement of earth around the sun. Okay, so earth rotates around the sun and revolves around itself. Alright, both of these movements are displayed by the earth. Alright, so there is equator, then there are two lines further. These are known as the tropics. The Tropic of Cancer and the Tropic of Capricorn. These are known as the tropics. And then there are poles, the poles of the earth. The northern pole here, and the southern pole. Now on these poles, the temperature is very low. The temperature is very low and there is ice. Okay, now let's move to the next part. This is the basic understanding. Now let's see, this is a polar region. This is a polar region. Okay, so if the ice is frozen, that means the temperature is well below 0 degrees Celsius. Okay, that is why the water is existing as the ice. Now, if due to the climate change, what happens? The temperature increases. The temperature increases. And it affects this polar regions also, which are very sensitive to temperature. Very sensitive to temperature. So ice starts to melt. Ice starts to melt. Okay, so this is our primary finding. Now, what is climate change? I have explained to you earlier also, but let us see again. This climate change is because of the greenhouse gas effect, the GHG effect. Greenhouse gas effect is when the sun rays come to the earth, but they cannot go back. Alright, they remain trapped, the heat remain trapped because of various different gases. Various different gases. The primary of these gases are, one is carbon dioxide, one is methane CH4. The water vapor also does this. Okay, displays this effect. Okay, so because of this effect, what happens? The sensitive polar regions which have ice led to the melting of the ice. Now ice becomes what? Water. Ice becomes water. And this water from the polar regions, coming back to this, so this water from the polar region goes towards the equator. Goes towards the equator. Alright, now what happens when the water on the polar region, you can see the ice here. Okay, now ice melts and goes towards the equator. Here is the equator, let's say. Okay, and from south side also, the water is coming towards here, towards the equator because it is melting. Now what is happening? The height here reduces. The height here reduces. And the width here increases. I am extrapolating this, not so much, okay, in reality, but a bit. But I am showing it, okay? So don't take it as completely real. So what happens? Instead of Earth being like this, it becomes like this. Okay, we extrapolate it. Alright, so now we will see what happens. If we see this as an axis of rotation of Earth, then we will see there is a difference between this radius and this radius. Alright, so this radius affects the rate of rotation. Okay, let us understand how. So this is known as the moment of inertia. Okay, now there is a concept in the physics known as the conservation of angular momentum. The conservation of angular momentum. All right. So basically what happens, you must have done or let's say seen an experiment where around your finger you can tie, let's say this is your hand. Okay, around your hand or finger you can tie a thread and tie a stone. All right. And now you can rotate it, start rotating it. Now, as it wraps around your finger, the speed of the stone increases manifold from the initial speed. Let's say initial speed was 10. As the radius decreases, the speed becomes 5 times, 4 times, 40, 50. Okay, whatever units you take, meter per second or whatever. All right, but the speed increases. This is because of the conservation of angular momentum. All right, this is the same concept because of which this is known as a figure skater. Known as a figure skater. So figure skater, you can see on the videos or YouTube anywhere, when they have to increase their speed, what they do, they become like this. Okay, then their speed increases very much. And when they have to decrease their speed again, they widen themselves, stretchen themselves. Okay, because of this, radius increases and the moment of inertia also increases. All right. Okay, next thing. So what does it matter to the earth? Okay, we all know that there is only a small quantity of water coming to the equator. Okay, and earth is very big. Earth is very big. The radius is approximately 6,000 kilometer. All right, so Earth is very big and there is only a small amount of water coming. So how much effect will it produce? So the effect that it will produce is very less, very less. So scientists analyze this effect. So they told that in let's say a time period of 100 years, 100 years, the effect that it will show will be 1.3 1.3 milliseconds. Milliseconds. That means 10 to the power minus 3 seconds. If this happens 1,000 times, if this happens 1,000 times, that means for these many years, 1 lakh years, then 1 second gap will come. Then 1 second gap will come in the Earth's time. Okay, so why should we care about this? Why should it matter? Okay, so let's see this thing. So, except for the timekeeping itself, we are not talking about, say, it's 2 p.m. So, what would it matter if it were 2:01 p.m.? Okay, or let's say 2:01, 2:00:01 second. Okay, it would not matter to you or me. We are not talking about simple people, you or me. We are talking about the technology here. We are talking about the technology here where precision is required. So, where the precision is required? So, we all are measuring time in terms of atomic clocks for humankind. Atomic clocks. Okay, so these are the clocks which are doing the timekeeping for us. They tell us very precise time on the atomic level. They tell us the time. All right. So these atomic clocks are also the founding basis for many technologies such as the GPS. Okay, the space technologies, the stock market technologies. Okay, where millisecond also matter, where the millisecond also matter, where we are, let's say, transferring the data. So if the Earth's time goes here and there, even by 1 millisecond, 2 millisecond, okay, then it will affect the atomic clocks and the technology that we are using. Okay, so which technology we will be, let's say, seeing an effect? So there will be GPS technology. Okay, then there will be stock market technologies, space travel and space technologies. So these sectors we will be seeing an effect. Okay, one more thing, that while this climate change is slowing down the Earth's time, there are other factors also which are accelerating the Earth's time or slowing it down or let's say affecting it. Okay, one of them is the gravitational power of moon. This is known as the lunar friction. The lunar wave friction. Okay, so as you know that Earth and the Moon both exert a force, the gravitation force, the formula of which is Gm1 m2 upon r square. Okay, so this force is very small, but it keeps the moon in its orbit. Okay, but moon also exerts a force which attracts the wave, the waters on the earth. Okay, so it impacts the time also. It impacts the time on earth also. Okay, so now we can see two factors. There is another factor also, third factor. Okay, what is the third factor? This is the core of the earth. As you all know that earth is divided into various different layers. Just a second. It is formed of various different layers. There is a crust, magma, core. Okay, crust, mantle, core. So the earth's core is slowing down. The rotation of earth's core is slowing down, because of which the crust is having more rotation or faster time. You can read about this on internet. Okay, so here we are now seeing three factors. One was the climate change, one is the lunar wave friction, and third we can see the core effect now. All right, now scientists have to see that how much overall these factors are affecting the earth's time. Okay, now this can become a great exercise, let's say, for the scientific minds also, because these are very big factor doing very small things. Very big factors doing very small things. So it becomes an exercise for the scientist to figure out that what will be the exact result for the earth. Exact result for the earth. Which party will win? The slowing party or the faster party, or let's say the factors which want to make the earth's time go faster. Okay, so they will have to ultimately account for it. The accounting is known as the negative leap second. The negative leap second, this is also a concept you should read about. Okay, so these are basically all the factors which are affecting earth's time. So we'll only see how do they affect the future and when does the effect come to results, let's say, or become significant enough for our seeing. So this was about today's lecture. This is Yatharth here signing off. If you have any comments, any feedback, you can let me know. Along with this, also happy 78th Independence Day to all of you. So I hope you enjoy the lecture and see you in the next lecture. Have a great day.